Hi students, today's class is about Unit 4 multiple integrals. The topic is volume integrals. Contents, objective and outcome, volume integrals in triple integrals, applications. Objective and outcome. The objective is volume integrals in triple integrals, and the outcome will be student get to understand about the concept of evaluation of volumes using triple integrals. Volume integrals in triple integrals, the definition is if f of xyz equal to 1, then the triple integral f of xyz dx dy dz denotes the volume over the given region V. That is the triple integral. Integrand function will be 1. So it is the required formula for volume. So volume V equal to triple integral over the given region V. The integrand function is 1 here, dx dy dz. It is the formula to find the volume over the region V. Evaluation of triple integrals region problem. Express the volume of the sphere x square plus y square plus z square equal to a square as a volume integral and hence evaluate it. So we have to express the volume of the sphere. So what is the sphere here? Sphere having radius a units as a volume integral, but we have a formula for volume, that is in triple integral over v 1 dx dy dz. Now we have to get the limits for z, y, x. Clearly for a sphere, for a total sphere, the limits of z are negative root of a square minus x square minus y square to positive root of a square minus x square minus y square. That is, z limits are in terms of x, y, and the whole volume region is considered in xy plane, so that y limits are in terms of x, that is y limits are negative root of a square minus x square to positive root of a square minus x square, and the ordinates of x axis are x varies as negative a to positive a. So these are the limits considered for whole volume of the region. If we considered the region only in first octant, so it is the figure related to only first octant. In first octant, we have to take the lower limits as zeros, that is 0 to root of a square minus x square minus y square as z limits, 0 to root of a square minus x square as y limits, and 0 to a the limits as x limits. So but here we have to consider whole sphere. So for this, these limits are considered. But here the integrand function is 1. 1 is a constant function, but we know that every constant function is always even function. So negative to positive root can be written as 2 into integral of 0 to root of a square minus x square minus y square. But what is the integration for 1 with respect to z? Z. So already we have known a formula here, that is integral of minus a to a f of x dx is equal to 2 into integral of 0 to a f of x dx whenever f of x is an even function. So that here also one is constant function, but every constant function is always even function. So 2 into integral 0 to root of a square minus x square minus y square. But what is the integration for 1 with respect to z? Z limits 0 to root of a square minus x square minus y square, substituting upper limit and lower limit as 0. Now clearly the triple integral sum is now reduces as double integration. Now we have to integrate with respect to y and then x. For this, a square minus x square can be taken as a sum b square. So clearly if we take a square minus x square as a sum b square when the integration with respect to y is performed, so that we can clearly obtain a formula here. So what is the formula? It is look like integral of root of a square minus y square dy, that is y by 2 root of a square minus y square plus a square by 2 sine inverse of y by a. So it is a definite integral formula, that is a 2 into negative b to positive b can be written as 2 into 0 to b, because the integrand function is here even function, because if we replace y with minus y we will get the same function, so that the integrand function is here even function. In case of integrand is even function, the limits can be written as 2 into integral 0 to upper limit, that is b. So 0 to b. Now we will use the formula, that is y by 2 root of b square minus y square plus b square by 2 sine inverse of y by b. But what are the limits here? 0 to b. Substituting upper limit and lower limit is 0. So substituting lower limit is 0, the total value becomes 0, because 0 by 2 into any number is 0. Sine inverse of 0 is 0. So substituting upper limit in place of y and then simplifying, but sine inverse of 1, but what is the 1 can be replaced with sine pi by 2. So clearly sine get cancelled, we will have pi by 2. So b square by 2 into pi by 2 is pi b square by 4. Now taken out pi by 4 as common, clearly 4 get cancelled, we will have pi b square. But what is a b square here? B square is not constant here. B square is a square minus x square. Just replace a square minus x square. But what is the integration for a square with respect to x? A square x, because a square is constant, just taken out, and one integration with respect to x is x, and x square integration is x cube by 3. Substituting upper limit and lower limit and taking the LCM as a 3, 3a cube minus a cube is a 2a cube by 3. So clearly 4 pi a cube by 3. It is the required volume of the sphere having radius a units. The required volume is 4 by 3 pi a cube cubic units. Another problem. Find the volume bounded by the cylinder x square plus y square equal to 4 and the plane y plus z equal to 4 and z equal to 0. So solution. So it is the rough sketch of the region x square plus y square equal to 4. It is the cylinder about z axis. Since z is missing here, we have to take the cylinder about z axis. And the plane y plus z equal to 4. It is the plane y plus z equal to 4, which intersects y axis and z axis. And z equal to 0 means xy plane. Now we have to find out the volume. For this we require z, y, x limits. Z limits are 0 to 4 minus y. So clearly z equal to 0, and we will have a plane, that is z equal to 4 minus y. So these are the limits related to z. And y limits are negative root of, so here the region, volume region is considered in xy plane. It is nothing but a circle, that is x square plus y square equal to 4. For circle we know the limits for y and x. Y varies as root of negative root of 4 minus x square to positive root of 4 minus x square, and x varies as negative 2 to positive 2. So these are the limits for z, y, x. Once again, so in volume region, we have to consider a strip which is parallel to z-axis. The lower part of the strip touches to the xy plane, so z equal to 0. Upper part of the strip touches to the plane y plus z equal to 4, so that z is a 4 minus y. So z limits are obtained, and y x limits for this. The volume region is considered in xy plane. It is of the shape circle. The circle equation is x square plus y square equal to 4. But we know that the limits for y and x for the circle, that is y varies as a negative root of 4 minus x square to positive root of 4 minus x square, and x limits as, so just removing y square, we will have x square is a 4. Thus we will have x is a plus or minus 2. From the ordinates of x-axis or the from vertices of x-axis, we will have minus 2 0 and 2 0, so that we will have x limits as negative 2 to positive 2. So hence the required volume, which is given by v equal to triple integral dz dy dx. Just replacing z, y, x limits. But what is the integration for 1 with respect to z? Z. we have to put upper limit as 4 minus y and the lower limit as 0. Now clearly triple integration is sum becomes now double integration. Now integration with respect to y, 4 integration is 4y, negative y integration is negative y square by 2. So hence the volume is, now we have to put the upper limit as root of 4 minus x square and lower limit as negative root of 4 minus x square, upper limit minus lower limit. These limits are substituted in place of y and then simplifying. So we will have these four terms, and so we will have negative term and positive term clearly here get cancelled. That is 8 into root of 4 minus x square dx. So here is 8 is constant, just taking out, and we will have 8 into integral of 0 to 2, because the integrand is an here even function. Negative 2 to positive 2 can be written as 2 into integral of 0 to 2 root of 4 minus x square dx. But already we have 8 here, 8 into 2 16. So 16 into integral 0 to 2 root of 4 minus x square dx. But it is look like integral of root of a square minus x square dx using the formula. But what is the formula for root of a square minus x square dx? X by 2 root of a square minus x square plus a square by 2 sine inverse of x by a. So using the formula, so we will have x by 2 root of a square minus x square plus a square by 2. But what is a here? 2. 2 square by 2 is 4 by 2 sine inverse of x by a. Now we have to replace upper limit as 2 and lower limit as 0. While putting lower limit as 0, the total value becomes 0, and putting upper limit as 2. So we will have sine inverse 2 by 2, sine inverse 1, but sine inverse 1 value is pi by 2. That is a 4 by 2 into pi by 2 is a 2 pi by 2. So we will have 2 ones, 2 eights, that is 8 into 2 pi is 16 pi. It is the required constant value, that is the required volume V equal to 16 pi. So it is the required volume region which is bounded by the given plane and given cylinder. Another problem, find the volume common to the cylinders. So two cylinders are given here. The sections of the cylinders, x square plus y square is a square, which is about z axis, x square plus z square equal to a square, which is about y axis. Or the circles x square plus y square equal to a square and x square plus z square equal to a square in xy and xz plane respectively. Here in the picture, 1/8 part of the required volume covered in the first octant is shown. So clearly the common region z varies from 0 to root of a square minus x square. So here it is the rough sketch of the region. So clearly we will have the two circles about these two cylinders whose bases clearly as shown in the figure. So these are the first cylinder, that is about z axis, that is x square plus y square equal to a square. Another cylinder is about y axis, that is x square plus z square equal to a square. So these are the two cylinders which are the taken as in xy plane and xz plane respectively. So here in this picture we can clearly uh, have a 1/8 part of the required volume, so which is covered in only in first octant. So clearly all three xyz are positives here. It is a positive octant. Positive octant is nothing but first octant. In this octant clearly z varies as 0 to root of a square minus x square, because the strip is taken as parallel to z axis. So that we will have z varies as 0 to root of a square minus x square. So for this region, the volume region is considered in xy plane. In xy plane, we will have a circle, but we know that the limits for the circle x square plus y square equal to a square, so that we can obtain the limits for y and x. So don't forget, here the strip is taken which is parallel to z axis, so that the z limits can be obtained. The lower part of the strip touches to the xy plane, so that z equal to 0 here. Upper part of the strip touches to the cylinder here. What is the cylinder? x square plus y square equal to a square. So that z is root of a square minus x square. So z limits are obtained. For remaining limits, we have to consider the orthogonal position of the volume region in xy plane. So here the xy plane region is look like the half circle, 1 by 8th part of this circle arc. What is arc equation here? X square plus y square equal to a square. So it is the circle equation, but we know that the circle equation limits, using the limits we can get the required volume, z limits and y limits and x limits. So, but here the volume is lies in all 8 octants. So that don't forget to multiply the volume with 8. So it is most important because the volume region which lies in all 8 octants. So don't forget to multiply the volume with 8 here. Now simplifying, first integrating with respect to z, the innermost inner integral, and then outer integral, and then outer integral. So first while integrating with respect to z, one integration is z here, limits are 0 to root of a square minus x square. So substituting upper limit and lower limit as 0. So root of x square minus. Now we have to integrate with respect to y. But while integrating with respect to y in double integrals, we have to keep x variable terms as constant. That is root of a square minus x square is keep it as constant. One integration with respect to y is y. Limits are 0 to root of a square minus x square. So again substituting upper limit and lower limit. But what is root of a square minus x square into root of a square minus x square? A square minus x square, because square and root get cancelled. But what is the integration for a square here? A square x. Negative x square integration, negative x cube by 3. Substituting upper limit as a and lower limit as 0. So we will have 8 into a cube minus a cube by 3. Now taking the LCM as a 3, we will have 3a cube minus a cube is 2a cube, 2a cube by 3. So 2a cube by 3 into 80 is 16a cube by 3. It is the required volume. So it is the required volume common to the two cylinders about z-axis and y-axis respectively. So hence answer is volume is 16a cube by 3. It is the required volume common to the two cylinders. Work for you. Calculate the volume of the solid bounded by the surface x equal to 0, y equal to 0, x plus y plus z equal to 1 and z equal to 0. So that means the solid is bounded with 4 planes. That means the volume region is tetrahedron. So you have to find out the volume of this tetrahedron. So here I will give a hint for you, that is limits for you. So clearly here for the given region z varies as 0 to 1 minus x minus y, because if we take the strip in the volume region, the lower part of the strip touches to the xy plane, so z equal to 0. Upper part of the strip touches to the given plane, that is x plus y plus z equal to 1. In that z equal to 1 minus x minus y. The whole volume region is considered in xy plane, so that we will have a right angled triangle as the region. So y limits as PQ is a strip, y equal to 0 to y equal to 1 minus x as y limits, and x-axis ordinates as 0 0 and 1 0, so that 0 0 1 0, so that x varies as here 0 to 1. So use these limits and find out the required volume. What is the formula for volume? Triple integral over v 1 dx dy dz. Don't forget the integrand function is 1. Whenever the integrand function is 1, then the triple integral represents volume over the given region. So evaluate this triple integral and get the result as 1 by 6. So it is about the information about the evaluating the volumes using triple integration. For any queries, please contact. Thank you.